Let's move on to the second talk, which is concrete pavement types selection. So when you would choose one type of pavement as opposed to another type of pavement. So a quick talk about the benefits of concrete roads. Then we'll talk about the selection and issues with jointed concrete roads and issues with CRCP. So benefits of concrete roads. They are stronger. So traffic volumes and axle loads are increasing worldwide, requiring stronger pavements. And there's a growing acknowledgement of the inherent strength and load carrying ability of concrete. Concrete pavements last longer, typical design life of 40 years or more, compared with 20 years for asphalt. In the UK, we have some over 60 years old and still going fine. Increasing cost of asphalt and other oil-based products. As you say, if you're in a country that doesn't produce its own oil or bitumen, then you have to import it at great cost. More durable than asphalt, particularly in high-stress locations. As I said, for steep slopes, slow-moving traffic, bends, or regularly flooded areas. And depending on the type of concrete pavement, less maintenance, particularly CRCP. Environmental benefits. Now, I know that producing cement produces a lot of CO2. So environmentally, that is an issue. But on the other hand, there have been studies that show that HGVs running on a concrete surface use less fuel because of the reduced rolling resistance of the surface. So you can see that there's a report there by EU Pave. So it can be up to 6.7% less fuel.
Did they consider the carbon emission during cement production?
That's what I'm saying. CO2 is a lot is produced during the cement production, so that's a negative. Can we take questions at the end, because I'm going to run out of time and then you'll have a lunch delay, so we don't want that. So let me press on. So concrete roads can better withstand extreme weather conditions. For example, if you have an asphalt pavement that's been soaking in water or flooding, water can get into the pores of the asphalt if it's slightly permeable, and then when it's trafficked, the pore water pressure will cause the asphalt to break up. Concrete, not so. CRCP, as I say, can breach small weak areas in the supporting layer. So if you have a localized area of weakness, that won't affect the road. And many countries can produce cement. So as we've heard earlier, you have your own cement production companies, and most of your cement is exported. So you can easily build lots of concrete roads if you have the aggregate. Climate change. In the UK, we had a record high temperature in 2022 of 40.3 degrees. So that's a record. It caused some asphalt roads to melt and some safety barriers to buckle. I've never seen this before happening to safety barriers. Look on the right there. It's a great photo, but I've never seen that before. Now, with the asphalt roads, it was just one or two that were affected, but you can see that there's lots of fatting up there, and the bitumen has flowed to the surface and actually stuck to tyres. You can see in the middle, it just got too hot. Now, Bangladesh is 80% floodplain and extremely vulnerable to climate change, cyclones, flooding. And as I said, prolonged exposure to water can damage asphalt if water gets into it. Higher temperatures and annual flooding could become the new normal. Now, I looked up some figures for temperature increase in Bangladesh, and you can see a plot there, although it's very small. which shows an increase of 0.5 degree since 1975. But the final few years are quite low, and the years before that seem to be sort of exponential increase. So I'm not sure about the next few years. It could carry on at a slow increase, or it could go quite high. Now, looking at rainfall has actually decreased since 1922. You can see the sort of the trend line going down, but there are more intense storms. Global warming has been referred to as global storming because of the unnatural weather patterns. So you're getting higher intensity of rain in a shorter time scale, which can cause flooding. So most engineers are familiar with some of the problems of asphalt pavements, as you can see there. But you may not be familiar with some of the problems of concrete pavements. So I'm not going to say they're perfect, and I'm going to show you some of the issues with concrete pavements later. So pros and cons of asphalt pavements. So I'm sure all the engineers here would be familiar with asphalt construction and maintenance. You have existing standards, procurement practices, etc. already in place. No specialist equipment required. An initial lower cost than concrete, although we've heard that may not be the case. Quick repairs, asphalt, you can just plane off and replace, or quickly fill a pothole. And generally lower noise than concrete. So the cons of asphalt. Design life is usually only 20 years. It can be susceptible to rutting if there's an incorrect mix or overloading or hotter temperatures. Susceptible to age hardening, leading to cracking, especially the very, very top film. Resurfacing is normally required approximately every 10 years. Thin or less dense asphalt roads will be more susceptible to climate change, higher temperatures and flooding. Asphalt roads are less durable in high stress environments, e.g. hills, corners, bus stops, approaches to junctions. And asphalt is more susceptible to overloading damage. We heard earlier that overloading is a big issue, so that's important. And high foreign exchange costs of imported bitumen. So concrete pavements, what are the pros and cons? A long design life, usually 40 years. Lower whole life costs, depending on the type of pavement you have. For example, CRCP, it's more expensive, but there's very little maintenance to be carried out on that. It doesn't rut. More durable in high stress environments, e.g. hills, cornering. More climate resilience, less damaged by high temperatures and flooding. Less susceptible to overloading. CRCP can bridge over weak areas. Concrete doesn't have age hardening. In fact, it gets stronger with time. So it doesn't require resurfacing every 10 years due to, say, UV degradation. Possible foreign exchange savings if bitumen is imported and cement is home produced. Fuel savings for road users. If you have a concrete surface, as I said earlier, there's less rolling resistance, so you can have fuel savings. Increased light reflection. I wasn't aware of this, but I understand that fewer light columns are required if you have a concrete surface because of the colour and reflection of light. So you can actually have a reduced number of lighting columns. So the cons of concrete pavement, obviously the higher initial cost, although that's debatable. Construction maintenance expertise required. That's true. If you're building a concrete road, you need to have expert supervision. Mainly specialist equipment. A concrete paver is normally different to an asphalt paver, except for roller compacted concrete. I understand you can use an asphalt paver. Repairs can take longer. Oops. So concrete lane, if you had to sort of do a repair in it, you can have that closed for 1 or 2 days. Obviously, there are rapid setting cements that can be fully cured within a few hours. Ride quality, that depends very much on the pavement type and construction quality. If it's hand laid, it's normally rougher than paver laid. And if you have a jointed concrete pavement, you have a joint every 5 meters, that can be rougher than a CRCP, which is paver laid. Noise can be an issue. Concrete roads are noisier than asphalt most of the time. So if a concrete road is to be built next to, say, houses, you may consider the noise issues for the neighbours. So it may be that you incorporate a quieter concrete surface, or you go for the type of construction which has an asphalt, a CRCB, a concrete CRCB base, but with an asphalt surfacing on top. Maintenance, depending on the type of pavement you have, for example, if you have a jointed concrete pavement, then you need to replace the joint sealant. That's important to stop stones getting into the joints and causing issues and stopping water getting down. So that normally needs to be replaced approximately every 10 years. Transverse joints can be problematic. I'll show you some of the issues related to transverse joints. CRCP, no problems. And condition monitoring inspection of a concrete road is different to an asphalt road. Okay, selection of concrete pavement type. So I've already talked about the main types of concrete pavement. Which concrete pavement type should I choose? The main thing would be budget. CRCP is the best, but it's expensive. Other options are cheaper, but they have maintenance issues. So it's a trade-off between your budget for construction and your maintenance costs. Traffic levels. If you have very few HGVs, then you could use a cheaper jointed unreinforced concrete pavement, would be suitable. If you have lots of HGVs, interurban route, CRCP is the best option. Environment. So careful consideration needs to be given to the suitability of different pavement types, different areas. For example, if you were to build in areas with known settlement, CRCP would be beneficial. If you're building a concrete road near the sea, then you need to use a certain type of concrete that is resistant, sulfate resistant cement. Ride quality required. So paver laid roads are smoother than hand laid roads. So if ride quality is important, it's better going for a CRCP option. Whether the project is a new build or rehabilitation. So if rehabilitation, depending on the traffic levels, UTRCP could be one of the options, one topic. Availability of local labour. If it's a rural road and labour is in plentiful supply, then you could do just a hand laid jointed concrete pavement, which will increase jobs for the local people and be less expensive, but the ride quality will be less. So here's a table which I put together. It won't all fit on one page, so there's 2 pages here showing the concrete pavement type, the traffic level suitability, a ratio of cost showing which are more expensive and which are cheaper, the advantages and disadvantages or shortcomings. So I won't go through all of those, but I understand you'll be given a copy of this so you can look at that table at your leisure. So it goes through the different types of concrete pavement. So issues with concrete roads. Now, in the UK, we no longer build jointed unreinforced concrete pavements. Or it's no longer in the design manual, although there is a design manual. You can build them, but only where there are existing roads of the same construction. Because what we found was that as jointed unreinforced concrete pavement reached the end of their life, so after 30, 40 years, what do you do with it? It's the rehabilitation issues that were of the main concern. So as I say, if you put an asphalt overlay on it, with a road with transverse joints every 5 meters, the asphalt will crack above each joint. I used to work in the Philippines, and what they do is they overlay it, the overlay cracks, so they overlay it again, and that cracks, and they overlay it again, and that cracks. I've seen up to 6 overlays on one concrete road, all of them cracked above the joints. So it's not efficient to do it that way. There are rehabilitation methods that stop reflection cracking. I'll go through some of these, but they are considered expensive. Here we can see some concrete pavement trials that TRL built in Zimbabwe. And this is just useful to show you some of the issues. So you can see that this is hand laid. They used bin lorries to transport the concrete. It was laid between formwork. You can see the dowelled joints being constructed there, and a vibrating screed to give it a nice surface finish. And the texture was a wire brush broom. So we monitored this for 7 years and did all sorts of tests on it. And it was a trial. So the whole point of constructing a trial is to get pavement failure. If you build a trial and it's fine at the end of the trial, you haven't learned anything. So they tried, in this trial, the concrete thickness was variable. There were places without dowels. There were some of them, there was a sub-base, some of them it was subgrade. And we learned lots of interesting things. Now you can see in some of the pictures the staining on the hard shoulder where pumping has occurred. Yeah. So these were in locations without dowel bars, and water's got in and mixed with the erodible subbase, and then been pumped out, causing settlement and cracking. We also did trials in the Philippines. As I say, their solution was just to overlay and overlay and overlay, and that didn't work. So we were trying lots of rehabilitation options, such as breaking up the concrete first before you overlay it, so you don't actually get all the movement at 5 meters. And it also CRCP overlays on top of the concrete pavement. So the major thing learnt is the layer underneath the concrete must be not non-erodable. That is the crucial thing that I've learned about concrete pavements. If you put the concrete on top of a granular material that's not stabilized, if it's jointed, you will get erosion at the joints. The water will somehow get in from the joints or from the sides, and the movement of the traffic will cause pumping, and it will be a headache as to what to do with the road after that. So it's crucial the foundations of a concrete road are very strong. That first picture is the M11 motorway in the UK. So you can see the concrete slab, then a granular subbase, and then clay underneath that. Now the M11 is one of the most problematic roads in the UK.
There are any thickness needed for the surface for strong foundation?
The subbase, I think, should be cemented. It's normally about 125, 150 millimeters thick. But it's crucial if you have a jointed concrete pavement to stop that erosion underneath every joint. As I say, rehabilitation is expensive. You can see it on the far right at the bottom. They are injecting filler underneath the concrete slab in order to fill that void and raise the slab back up to level. So imagine doing that for every single slab. It's very expensive.
That with the concrete slab, we are using the lean concrete layer of 100 millimeters.
Yes.
So is it not enough to protect this pumping action?
Yes, it's enough. It's yes. So joint sealant. So as I say, for jointed concrete pavements, transverse joint. What some people do is they just do the saw cut and then just pour a bit of bitumen in there. That's not enough. That's not good. You need a very flexible material, and it needs to be the right shape and location. Some people fill the sealant right to the top of the concrete, and then when the concrete expands, the sealant pokes out above the top, and as you're driving over, you get da-dum, 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 and you think you've got a flat tire. So the final level of the sealant should be a few millimeters below the surfacing of the concrete. It should also be the right shape. If I had a piece of rubber here that was rectangular and thick with two handles on it, if it was shaped like that, and two people tried to pull it apart, they couldn't. Whereas if you turn it on its side and it was flat and in that orientation, then people could pull it apart, put it back together again. So that's the shape of the sealant that you want. So
Is there any specification of what this sealant, perfect sealant by TRL?
there's a British standard on it, yes. So with the saw cut, that you've induced the crack, now you come back with a two-bladed saw and actually make the sealant groove. So you saw cut it again to the correct width, and then you put backing tape down. Well, you hoover out the joint, then you put backing tape, and then you put back a rod, which gives it a circular shape at the bottom, and that's a good joint sealant. Regular maintenance. Joint seals do deteriorate with age. I've been to so many concrete roads where the sealant has become detached both sides and water's getting in. But the main issue is detritus getting in there, stones and sand. Because if the joint is full of incompressible material, when it expands, it can't expand that way. So it will go that way. So joint sealing is crucial for jointed concrete pavements. Another thing people don't appreciate is that with jointed concrete pavements especially, you have a weak area at the joint and at the corners. So you get a lot of spalling where the edge breaks out. And this can be shallow, which is sort of half the depth of the slab. So you can just break it out and replace it with fresh concrete. But it can be deep, going down to 3/4 of the depth, in which case you have to break out the whole joint. So you can see some tools there, scabbling tools, breaking out corners, and replacing with fresh concrete. In the UK, if you have a jointed unreinforced concrete pavements, you have a joint every 5 meters. If you have to replace a slab, don't do it with asphalt, because what you find is there's no load transfer between the concrete slab and the asphalt slab. So there's lots of movement there. So if you replace one slab with asphalt, what you find is that then the next slab will fail by cracking, and that will have to be replaced. I've been to some places where, you know, there are 5 or 6 slabs of asphalt because one was replaced and the next 2 failed and then the next 2 failed. So always replace failed concrete slab with concrete. In the UK, what we also do is if we take a slab out, we replace it with a slab with reinforcement in it. But you also have to reinstate the joints because you still want that ability for the concrete to expand and contract every 5 meters. So other issues, locked up misaligned dowel bars. You can tell from the type of failure at the surface as to how deep it is and what's going on. So you may need, as I say, if the dowel bars are misaligned, then when they open and contract, there will be pressures in there that will cause the concrete to fail at that location. Blow-ups. As I said, these are extremely rare. I think 2 of these were UK, ones in Europe. Very rare, extreme heat. It could be that detritus stones have got into joints, so they can't compress, they can't expand, and eventually 2 slabs will do that for replace. But that's a very rare occurrence. Asphalt overlays. As I've said, because of the differential movement between the concrete and the asphalt overlays almost always crack above joints. And as I said, asphalt inlays, if you replace the slab, doesn't work. In the bottom right, this was taken in the Philippines, where every year guys come out and put asphalt on top of concrete, and within a few weeks it fails, it's sort of washed away. So always replace concrete with concrete, don't patch it with asphalt. In the UK, we have developed methods to increase the life of concrete pavements that are coming to an end. For example, putting asphalt overlays on concrete, saw, cut and seal. So in this technique, the asphalt overlays put on the jointed concrete, but then the asphalt is sawn directly above the joint. So it requires accurate marking of where the joints were, because once you pave over it, you don't know where the joints are. So you put accurate marking at the edges, and then you saw cut partial depth of the asphalt, the whole width. So you saw cut to approximately 1/4 of the depth of the asphalt, and then put a flexible sealant in there. And that way, the asphalt can move with the concrete slab and there's no cracking. But it's an expensive technique. So saw cutting every 5 meters is laborious and time consuming. And if you have to replace the asphalt, you've got to do the same again. Crack seat and overlay. One of the techniques that's been developed for rehabilitating concrete pavements when they reach the end of their life is to crack and seat. So what you're effectively doing, excuse me, what you're effectively doing is breaking up a 5-meter slab into 1-meter slabs. So you come along with a huge guillotine and you whack the concrete and break it into 1-meter sections. And you can see the huge great guillotine breaker down on the left-hand side here. Goes up, down, pulls it back. So you can see that instead of a large movement every 5 meters, you're getting a tiny movement every meter. So then when you overlay it, you don't get reflection cracking. But in the UK, the standard is 180 millimeters of asphalt, which is a lot. It causes problems at overbridges where you have the height clearance. So instead of going up 180 millimeters, they have to take the concrete out and go down.
But if too thick asphalt is used, then again the probability of rotting. So
Yes, if overloaded vehicles, yeah. But here you're talking, in 40 years' time. So that's why in the UK, jointed concrete pavements are not used anymore because of these issues in 40 years' time. Now you can do the same with CRCP. For example, in the UK, there were trial sections of CRCP where there was only longitudinal reinforcement, no transverse reinforcement. And they have developed longitudinal cracking. So what do? Do you dig it up and throw it away? In this case, what happened was there were saw cuts done down through the reinforcement every meter, sever the reinforcement and split it up into CRCP into 1 meter lengths. So you saw cut, then you whack it, breaks through the concrete, and then you overlay it in the same way. So an expensive treatment, but that's only for 1 or 2 CRCPs that were built incorrectly in the first place. So issues with CRCP. So on the left, you can see neat cracking that's occurred every half a meter or so. On the right, it's a poorly constructed CRCP road with very wide cracks, a longitudinal crack down the middle. So that was a very poorly constructed CRCP road. The main problem with CRCPs is punch outs and spalling. So where a longitudinal crack meets a transverse crack, you can get small areas of failure that are punched down into the subbase. Excuse me. But they are very few and far between. Most CRCP roads, there's no problems, but you can get occasional issues. So there we go. We've talked about the benefits of concrete roads, the selection of concrete pavement type, issues with jointed concrete roads, and issues with CRCP. Finally, with building a concrete road, don't let people drive on it before it sets. Here you can see an old gentleman got confused, went the wrong way, and drove into the wet concrete. So don't let that happen. Thank you. Any questions? I know there will be.
Specific regarding that reinforcement, IRCP, either it should be top or it should be top and bottom.
So the reinforcement is normally, I think it's at a third depth. You don't want reinforcement too near the top because it can be exposed and then could rust. You don't want that happening. So I think the standard is for it to be at a third depth of the concrete.
So it should be single layer or both layer, or people layer.
I've never heard of a multiple layer. We only use single layers.
All is single layer.
Sorry?
All is single layer. For jointed pavements.
For joint as well as CRCP.
Yes,
The jointed reinforced, if it has reinforcement in it, it's just one layer. One layer. Same with CRCP. One layer of reinforcement.
Also CRCP single. But in our project, we are using it as
Two layers.
two layers. And it was main
Maybe-
reinforcement as well as.
Maybe it's thinner reinforcement. Thinner reinforcement, but two layers. That'd be interesting to see the results. Yeah.
But from your design section, as you shown earlier regarding the crack formation of 0.5 to 2 meter interval, you have shown that the cracks will be formed in the full depth of the slab. So do you think that to protect this crack, to make it a very tight position in the bottom part, that bottom layer of reinforcement is also important. Because of cowling and thawing effect, both top and bottom of cracking will be formed. Top down cracking and bottom up cracking both will be formed even in the CRCP or in the GRCP, both types of pavement. So why we are not using the two layers of reinforcement, though the top layers importance is too much because it is directly facing the moving load and it is exposed to the surface, it is exposed. So and the probability of infiltration of water is too high. Because of that, the amount of reinforcement in the top layer is maximum. And in our design, it has been suggested by Professor Samsullah, the minimum reinforcement in the bottom layer also. And if you see the ASTO 93 guide, you can see that they have also proposed a 2 layers reinforcement if the thickness exceeds 14 inches. If the slab thickness exceeds the 14 inches.
What's that in centimeters?
The ASTO.
Yeah, what's 14 inches?
14 inch.
It takes slab.
Yeah, yeah,
Thickness of the slab, if it exceeds 14 inches,
yeah.
then they have suggested for use of 2 layers reinforcement.
I'll work in centimeters. So I'm trying to work.
Centimeters, it is 35 centimeters.
Yeah, 350 is a very thick slab.
That is heavy duty pavement, if exposed to the high traffic, high volume traffic and high heavy loaded traffic. In that case, they have suggested 2 layers. 5 centimeter, if the slab thickness more than 30, but TRL is not suggesting like that.
I can't remember the maximum thickness, but I think it's about 300, something like that. But we normally use just 1 layer of reinforcement. Obviously, it's crucial to stop water getting down there. So reinforcement is at the top and holds it tight together.
Just one issue actually, I don't know, I may have missed. So what should be the strength of concrete, let's say? 25 megapascal or 40 megapascal?
Maybe 16. No problem.
This guide is not a manual, so it doesn't explain the strengths of concrete required or mixed design. Mixed design is very complicated. It depends on whether you're hand laying or laying by paver. Your mix will be different. So we can't in this manual go into all that level of detail. It's normally a C40 concrete.
In actually, Bangladesh, we use C40, in some cases we use C35s. I think it's okay, yes, 35s.
Any more questions? Yes.
Good morning. You can hear me?
Yes.
Very nice presentation, very informative. Some questions regarding the foundation. I think you have mentioned something about non-electrical spine base. About the foundation of the concrete pavement. Would you like to elaborate anything, or is there any more detail in the side guideline of this new one? And what about, if we are thinking about a concrete pavement near, very near to some water body, is there any guideline on that? Because there is a strong case of seepage. And what to do in that case? Should we be going for concrete pavement, or should we think about something else? Any guideline or solution regarding foundation also?
As long as the foundation beneath the concrete slab is not erodable. That's the main problem that we found in many different countries. That we would recommend a cement bound subbase beneath concrete pavement. So you've got the concrete slab, then cement bound subbase. I'm not sure what you mean by leaching. What was seepage? What do you mean?
I've seen the concrete pavement that has the water body just adjacent to the road. So what happened was when the water just came down, it was part of the flash flood area. When the water went down, it took several sections of the road. So out of the 7 kilometers of road, almost 2 kilometers went away.
So you're saying the whole road was washed away?
Not the road was
Sections of it, yeah.
So let's say 5 sections got lost. And the foundation was only I understand. So have to be able to see this kind of foundation. That's why I'm asking. This kind of scenario where flash flood occurs, where you see a lot of wave action, because the water has a lot of forces. It goes down, but it comes and it goes. So it took the whole concrete section.
It took the whole concrete section out, yeah. I think if it was an asphalt road, it would have done the same. If it was an asphalt road, it would have also washed it away.
Asphalt.
Asphalt, yeah. So in that situation, I don't think it matters whether it was concrete or asphalt. If the whole foundation and the road has been washed away in that location, it doesn't matter what the road is built of. Obviously, in that location, you need to have drainage from the mountain going underneath the road so it doesn't affect it.
Not the case in any other, let's say not a flash flood area, but somewhere the water body is just adjacent to the road. In that case, should be thinking of something like water sealant, some way that water does not touch the slab. So is there any cement we should be using at the bottom part of the slab? Any way to waterproof the foundation, any guideline on that?
No, I mean, if you know the locations where water is coming down to the road, so you can build in drainage, proper drainage that goes underneath the road, it comes out and doesn't actually affect the road.
I have seen locally in some roads in Chennai, that they have bent the slab and penetrated the slab some half a meter or 1 meter. Very deep. You understand, it bent the slab. Bent the slab like cut off wall. You know, they hold the slab, they bend at the edge and put the slab with 1 meter bent below the road level. Then if flood comes, they cannot wash away the inside material.
That's more part of drainage design rather than the actual pavement design.
That's not the load. At the is we are not putting double bar. So transport the load at the discontinuous end, some drop is provided there.
So you're not, a jointed concrete pavement, you're saying you're not putting dowel bars
At the
at the joints, yeah,
but at the edge,
at the what?
at the edge of the
Edge.
pavement, they are providing some drop off to transport the load properly.
Sorry, I'm not.
They are providing some resources to transfer the, I think something like.
A dropout.
Maybe some open it, but.
You want to draw a picture? I have a board here.
Normally, at the edge of the pavement, the pavement is discontinuous. Pavement is not continuous. Normally, at this, suppose at the joint, the pavement is discontinuous. That's why we provide down bar to provide the load transfer. Similarly, at the edge, if we do not provide any wall below the edge, then it will act as a discontinuous edge.
I think he's talking about the support below the longitudinal dash. Right. So that it can work as a beam for the slab.
Okay.
Very good at drawing.
Yeah, good, right.
The concrete slab without
The dowel, yes.
dowel bars.
That's great. It's a very change.
Um,
Passway.
on the edge.
Transfer distance.
Longer. Okay, talking about the long directional edge. Yes, yes, yes. Then the design, the load transfer mechanism will change, I think.
Yeah. That's why they're making this transfer back.
Yeah.
Sir, longer tomorrow, material.
Instead of having a side shoulder on here. We'll make this one out. I see what you're saying. In the UK, we were normally put a tight shoulder here, so that traffic running in the edge is not causing damage to the edge of the concrete. So it's a tight shoulder that's protecting the edge. But what you're saying is you're making the concrete actually thicker at the edge, which will protect it more. Yes, that seems a good solution. But maybe if it was a very important witness. Okay, yes, okay, that should work.
May I add something regarding?
Are we moving as per time or not? That's my question. The discussion. So please mind the time.
Okay.
Yeah.
Two important things, I think two important parts of the concrete pavement construction has been missed here. I would like to mention those two sections. One is the time of placement of concrete pavement, time of casting, with the relation with the temperature of the day. Whether laying at the morning time or midday or in the evening time is better, that is one issue. Another is the very important, the most important part, that is the curing, the timely curing and adequate curing. When it should start and how long it should start. This is very important for quality control and life longevity of the pavement construction. I think these two chapters, two sides have been missed. And from my observation of 18 years, what I have seen that the evening time pavement laying is better in the tropical country like Bangladesh, because in the morning time the temperature rises with the passage of the day up to the mid of the day and then decreases. So heat of hydration is added with that rising of the temperature and it causes the large effects to the pavement structures. So, but apart from this, if we see that the evening time temperature, when the laying is done in the evening time, then the days goes and at night time the temperature of the air temperature falls, which acts reverse to the heat of hydration. As a result, the resultant temperature falls. So the possibility of crack formation, earliest crack formation is reduced. This is one issue. And the time curing, that is the when should that curing should start. Normally in our country there is a normal practice that the whole day casting continues up to the evening. So it starts at the very early in the morning and ends at the evening. Then everybody goes for sleeping, and the next day they start for making the ponding with sand and cement, and it takes some time to be hardened. So another day passes. So after that, after 2 days, say 40 or 48 hours, actual curing starts. By this time, lot of damage happens in the pavement. So this is a very important issue. So we have changed this technique in our project in foreign countries. What is practiced? The chemical curing, membrane curing is done. But in our country, it is not available and very much expensive. So we have innovated a modern method in our country context. That is the mud curing. Spreading the mud just after completing the laying of the concrete. The initial setting time passes. We spread mud over the slabs and it spread water over it. So it can hold water for the whole night. So day after casting, we make the pond with the clay and watering by watering. So it gives a very good result for quality and controlling the cracks. So I think this is very important for quality control. It should be followed. Thank you very much.
Yes. Curing is an important part of building a concrete road, but this is not a manual. It's not telling you exactly in detail how to do everything. It's a guide and it's mainly pavement design. So curing is important to form the chemical bonds within the concrete. You have to prevent the road drying out. So there are various options. You can spray a curing membrane on top of the concrete so that it's protected from drying out, or you can have a tent over the road to stop the sunshine and affecting the concrete. And also you can put wet hessian on top of the concrete, again, to stop it drying out, and regularly spray it with water. But this level of detail is too much to go into a guide. You could ask about, what shape does the form work? All the little details. There's too much to put in the guide here. It's not a. Okay.
So I have a follow-up question. So you talked about the asphalt thin layer over the top of the paint. So my question is mainly this practice advice. So when we start doing the wiring post, should we put a tack coat, or what kind of tack coat it should be? And when we can start putting the wiring post, after fitting time or after matures, what do you advise?
So you're talking about during construction, if you're building a CRCB or something where you're putting in asphalt surfacing during construction. Yes, a tack coat is required. You've got to stick the bitumen into the concrete. I'm not sure how long you leave the concrete to set before you put the asphalt on top. I'm not sure. I can look that up.
Thank you very much for your deliberation. I want to ask one thing, that there is one initial setting time and final setting time. After initial setting time, we find some crack in the concrete road. So can we reevaluate it? Because after initial setting time, it cannot mobilize. So if we evaporate and crack can be reduced in this way. What is your opinion?
If you're building a long length of concrete road, you're not going to open it to traffic in a week. You're going to build the road for many months and then open to traffic. So I don't think that's an issue, opening it to traffic. If you're doing a repair, obviously you need a quick setting concrete to open the road as soon as possible. With regard to cracking, it depends what sort of crack occurs. You can get just surface shrinkage cracking if you're not curing the surface correctly, or if it dries out, you can get shrinkage cracking appearing, which is not structural and is not an issue. If you do get a serious crack, depends on the type of concrete pavement you've got and how to redress that issue.
May I? Excuse me, may I ask one concern? Hello? Yeah. Sorry. Okay, all of us worried about the cracks, right? So can we use UHPC, I mean ultra high performance concrete, where as we know that micro steel fibers or polymer fibers are used, and that has got a tension capacity as well. So do you have any experience about using this kind of ultra high performance concrete, especially in Bangladesh context, since all of us mentioned about the aggregate price of aggregate, and in UHPC we normally use sand as the main aggregate. So what is your experience? Can you use UHPC? And also another one, at this moment I saw in Australia they are using geopolymer even for airport pavement. Okay, so these two kind of concrete type, UHPC or geopolymer, can we use? And from the structural point of view, against wider kind of slabs can also be used. Do you have any practical experience or case study, or you can refer this kind of practice is done anywhere in the world.
That's a very simple answer. No, I don't have the experience of that. Obviously, there are different materials that you can put into concrete, steel fibres, other types of fibre. But that's at a level that's above this manual.
Okay, I think, let me give an announcement for timekeeping, yeah? So I was a bit late to come here to manage the whole event, hopefully I thought it's running very smoothly, yeah? So if we allow many questions, definitely we can have. So I will be requesting one thing to you, so we have a very intelligent audience here. To their questions, I can understand, yeah? So please keep a, as you have said that your document is there in the website. So make an arrangement so that any of the participants who might have different questions for observation, so that they can get back to you through the email or whatever, maybe the, media we feel suitable. And the next part is, I will be telling you that we did a very good job yesterday as far as timekeeping is concerned. So we want to do the same thing today, so that we have to follow the time schedule. And one thing we did yesterday that we reduced the time for break about 15-20 minutes. So can we do the same thing for today? If we can, so you can start the next presentation at 1 and take us to the lunch, and then they will be having some incentive. The part is finished now, and the other part will be finished later on. So please do that. This is the timekeeping instructions for running this session. Thank you very much. So we are not allowing any questions for this presentation. Please move into the second one, unless and others we have something else. Okay, thank you. Thank you.
So lunch is due at 12:30. Is that correct?
Yeah, we continue.
Continue?
Yeah.
So I'll start the next presentation, but there won't be time to finish it, and then we'll stop at 12:30.
We'll be giving a break of 45 minutes. Yeah, next.
Okay. Right. Third talk is a concrete pavement design worked example. So now in row note 31, we have basically used the design method from Ostro's. It was difficult because if we use the UK design method, it's for a different climate, and we're not sure how that would be suitable for a tropical and subtropical climate. Because in the UK we have such a range of temperature, it may be that we're over designing the concrete, which we don't want to do. So we've chosen the Ostro's method because that is in the correct tropical and subtropical climate. So the Australian method is a mechanistic empirical design method. So a mechanistic design is basically using a model, and empirical is based on results or experience. So mechanistic empirical is using model, but with real results for stresses and strains and deflections that result in failure. So here we go. This is the mechanistic empirical method, where you put in a concrete thickness, then you calculate the values for fatigue damage and erosion damage, and then you calculate those, and if the result's less than 100, it's okay. If one or more of those is more than 100, then you increase the thickness and repeat. So here are the two failure mechanisms. One is fatigue, which is the stress at the bottom of the concrete. And the other is erosion of the subbase beneath it. So here's an example. So jointed unreinforced concrete pavement with dowels and concrete shoulders. Now, one thing I should say is that the Australian method is not easy. In the UK design method, I'm used to a chart where you look at the traffic, you look at the concrete strength, the foundation class, and you read off the thickness. So it takes you 30 seconds. The Australian method is about 10 pages of very complex equations. So I'm sorry if your brain hurts after this. I'll not go through all the equations, but we'll whiz through and give it a design. Okay, so the concrete pavement you want is with dowels, tied concrete shoulder, a 5% reliability, a subgrade design of 5% CBR, and 28-day flexible strength of 4.5 MPa, and design traffic of 30 million HVAGs. Now that's not MESA. So the Australian method, the traffic is calculated in a different way. So I'll try and talk you through that. So in the Australian method, you have heavy vehicle axle groups. So they are saying that a damaging effect of a super single tyre is different to the normal dual tyre. So you have to count each separately and work out the traffic based on the axle group. So it's slightly more complicated than the normal method, but it should be more accurate because it's taking into account the new super singles. So once you've done your traffic count and for your particular road, you'll come up with a traffic load distribution. There's an example shown there. Now, the steps in the manual, there are 20 steps to go through. So sit down at your desk and prepare for a long morning. So first of all, your answer is JUCP, step 1, step 2, tied shoulders, step 3, traffic level. So your minimum subbase thickness by type is 150 mil of lean concrete. Step 4, the effective subgrade strength, CBR. So if you've got 150 mil of lean concrete and your native subgrade CBR was 5%, then the effective design CBR is taken from that table. That's quite simple, 73%. Step 5, your flexible strength is 4.5. Step 6, your 95% reliability. So you select a load safety factor, which is quite simple off another table. So 95% reliability, so JUCP doweled is 1.2. Then you select a minimum concrete base thickness from that table based on pavement type and design traffic. So your minimum concrete thickness is 200 millimeters. So that's what you use as your initial thickness, and then you go through lots and lots of complicated equations to see if that is suitable. So it's all explained in the manual. I don't think I'll go through every single step because there are 20 of them, but I'll just whiz through, and I'm sure you want your lunch. So I'll whiz through step 8, calculate the expected load repetitions of each axle group within each type. So you have a spreadsheet there where you input those. Giving you a proportion of loads for each axle group. And lots of complicated formulae later. You can see there's one example of an equation. So if you've got a maths degree, that's fine. And lots of other spreadsheet calculations, which I think is too difficult to go through now. But if you've got this presentation, you can follow this example. And also in the manual, it gives you clear steps. So there's another fantastic equation. And using the values that you've already calculated or taken from a table previously, you work through the example. I'm not going to go through all of this. Lots more complications. And the end result. Oh, and it's step 11. Gosh. Right, so we got through to step 17, and the final design is 200 millimeters thick concrete over 150 mil of lean concrete subbase. So it's a very complicated method of going through lots of equations. There is a simpler method, which is to use the Ostrodes software, which is downloadable from their website, and that is more like a black box. So you put in all the data, and it comes up with the results. The trouble with that black box is that if you ever want to tailor it particularly for Bangladesh and the conditions that are here, if you use the software, then you can't change any of the parameters that are inbuilt for Australia. It may be that you can change traffic settings and other factors, but if you've got all the equations, then you can work out if there's any specific changes that are needed for Bangladesh. Thank you. So that's perfect timing for lunch. I'm sorry I haven't gone through it all, but I think I think just before lunch it's a bit too heavy to go through all these small questions. Yes.
The meaning of reliability 95%.
The reliability of 95%. It depends on the class of road that you're building. So the reliability of that road. So if you're building a very important road that's between two important cities, you want reliability to be high. So you want a 95% or 97.5% reliability. You want this road to be good. So that's converted into a load safety factor, which is like the 5 percentile. So only 5% will fail, which is a good reliability. If it's a less important road, you can have less reliability.
Okay. Can it depend on the safety factor?
Sorry? It's the same thing. It's the same thing. Yeah, there's a table in there which is load safety factor and reliability. Okay, any more questions?
Design of reinforcement. You have shown the unreinforced. You want to know the CRCP design and the DRCP design.
I don't have a copy of the manual myself, so I can't show you.
Please share with us.
It's so rare at the moment. Yeah, there are tables of reinforcement size and
And also
frequency of
also
path.
the design of the joint because
So
dowel design.
the down, yes, that's all in.
Design, so,
Yes.
the joints.
Yes, that's all in there.
So you are done, yeah?
Yes.
Okay, so for the presentation part, we are done and hopefully we will be moving to the lunch now, yeah? So before moving to the lunch, let's take 20 minutes of time regarding what I have seen here. That you have rightly said that we use the Oster because it quite resembles the weather situation condition of the wheel of exercise we are doing tropical and subtropical business. But other way you also said the Australian guy is bit difficult to take into operation. So we have to make a trade-off. So what I could see here is we always base our equivalent standard access, but here the classification is coming up as a the heavy vehicle and the axle spacing the way it is. The thing is that the vehicle class or vehicle configuration in this country may be quite different to that one. So there is scope to customize to this context as far as the calculation of the load is concerned. So our problem, what we felt is like for classification of vehicles. For example, when we classify the vehicle, particularly for registration purposes, and we do some classification for our tooling purpose, and we do some classification for design purpose. So these three different same vehicle are being classified by three different agencies in three different manners. So that is creating a big problem for us. So there should be only one classification so that data could be retrieved by the highway agencies, not frozen highways, not LTV, or not the city corporation. So it gives the similar message across the city. So the thing is, the way it has been presented here, that could be a good understanding for you, not for us, because as a professional, we cannot straightforward use this one. Rather, it will be making our case difficult because we don't have the data input that demands to use this one. So that's the point I want to back. And the other thing what I say is, if we move into the guidelines, for these there are software for calculating that you said that was the end of the presentation. Similarly, for designing this flexible pavement, the Ostrod has the Starkey software. So they use this software for calculating this, different layer thickness and all. So as the head of technical services, I came across these two calculations. One used by the Astro, another Astro Imperial, another is Astro MEPDZ. You got the point. And the Starkey Ostrod. In many of the cases, I found Ostrod and Starkey calculations. If it is right, I'm not sure because I didn't go to the base because my desk officer did this calculation. It was brought to me for approval only to look at things. But that is my own experience. I came to. The thing is, while we straight away following the Ostrod guidelines, the design thickness is coming more than the Astro one. Then I said, compare these two. Which one is less? Go for that because economy is my first consideration. Because that's again, established guidelines, established guides. We can use that one. So the thing is, as we have said, that this software that is there and they're very classic, the formulas are there very key. But the thing is, if you have more formulas, we have to have a good number of inputs for that. So as far as the overall efficiency is concerned, like EPS system is very straightforward, 3 steps, with these things, you can get rid of them. So the countries where this guide or note, whatever we call, is targeted for, my observation is should be more straightforward so that they can use it with minimum data requirement. You got me? So this is what I actually wanted to give my overall comments from this. And our point is, if it is possible, synchronization of load, class, and others. So input data requirement, because we cannot go for collection of data for every single design. Because we have our HDF survey, we have our Excel note stations, we have other cloth stations. So they are collecting this data and measuring the weights every single time. So we can get this data and we can straight away use this data for design, developing design or as an input to that. That is what I wanted to say. That's my reaction to the presentation that is happening. So if we don't have any more presentations, so the thing is, you don't need to respond to all that question as ever I said. So keep these things in your mind so that these things, if there are scope, you can take into account. And my final request would be, many of our experts give you some opinions. And if you can compile all these comments, what your response? And if you can share, because everybody signed the email also, yeah? So along with your things that is available online, but we also want to know what issue was raised and what was your response. So like extended minutes of today's discussion. If you can make it available to us, that could be a good, material for our own consumption. Thank you very much.
Now, when I said that was the end of the presentations, after lunch, we're going to have a presentation from someone from Southampton University. And then after that, I would like to give a very short presentation about some of the new things coming from UK. And I also like feedback about the main issues for roads in Bangladesh to give us more information about what you see the problems are. I know that traffic is certainly an issue. I was driven from the airport to the hotel. Oh my God, the traffic. It was very busy. We were trying to spot a car without a dent in it, and there were many. So
heavy vehicle axle group you have shown in your design, different type of heavy vehicle axle group. Different types you have shown in a table. I think explanations are needed. What are the classification based on which group from, because in our country which axle group matches with what we need to find out. Single axle with single tires, the single axle with dual tires. So these are, I think, very important.
It's mainly just splitting out the super single tyre as opposed to the normal conventional dual tyres. So instead of having one lot of data, you have two lots of data, because the research that's been done has found that super singles are more damaging than tandem. Super single tyres, they tend to stay in a rut, for example. They don't climb out, they go straight. So many countries are adopting the system whereby you traffic counts, you separate super single tyres from dual cars.
Sorry, can I just respond very quickly on the issue of the axle loads and vehicle classification? In the guide comes with a spreadsheet, which you'll find together in the package. I'm going to hand over the presentation there. Now, in that spreadsheet, it allows you, it's an open spreadsheet. You can actually enter your vehicle, your heavy vehicle classifications that you have in your country and the type of axles that those classifications have. For example, you can say vehicle class type 4. They have a single axle at the front, two at the back, like that. So it's an open spreadsheet where you can enter all of that. Now, the next thing which you can do with the same spreadsheet is you can take axle load data from a weigh bridge in the vicinity of your project, and you input that in, or from your actual axle load survey for your project, and you put that in. The moment you put that in, the spreadsheet will automatically develop this distribution, and the only thing that you'll be left with now is inputting the subgrade strength, selecting what kind of subbase that you're going to use, and then you iterate the thickness So you just iterate the thickness and you come to a thickness. We appreciate.
Even the strength of the concrete should be.
Yes, sorry, it's also entered. And it can, there's a simple formula for converting from UCS to flexural strength. Now, the other thing which, of course, it also does is you can select whether you're going for a doweled or an undoweled or tight shoulder and so on. And it will generate that thickness. Now, there are factors for those equations. And because it's an open spreadsheet, if you calibrate it for Bangladesh, for example, you can adjust one of those factors, and that's how it works. So that's what I just wanted to clarify.
One thing I would like to know, you have shown the axle, the heavy vehicle axle group, but load limit not given here. If the maximum load limit is given for every class of heavy vehicle axle group, then it would be better to understand and convince our policy maker for design of a concrete or any pavement. I think it will be helpful for us. The maximum load limit for each type of axle group. It's important.
Okay, that is understood. Thank you.
I think we can